Have you ever looked at a world map and noticed how the continents look like puzzle pieces? Like South America could just slot right into the side of Africa? Well, it's not a coincidence. Today, we're going on an incredible journey back in time, billions of years, to uncover the epic story of Earth's lost supercontinent. Get ready, because this is the tale of how our world has been built, broken apart, and rebuilt again and again. Our story begins in an almost alien world, about 3.6 billion years ago. The young Earth was a chaotic place, mostly covered in a global ocean. But deep beneath the waves, something incredible was happening. The planet's first continental crust, called cratons, started to form. Think of these as the ancient, stable hearts of our modern continents. Around 3.1 billion years ago, two of these cratons, the Kopfel Craton in modern-day southern Africa and the Pilbara Craton in Western Australia, are thought to have come together. This union formed what some scientists call Vaalbara, our planet's very first, albeit hypothetical, super. It wasn't a giant landmass like we might imagine today, but it was a small but significant gathering of land in a vast water world. As hundreds of millions of years passed, more and more land was created. Volcanic activities spewed out new rock, and smaller landmasses collided and stuck together. By about 2.7 billion years ago, a larger supercontinent called Kennerland had assembled. This was a more substantial world, home to shallow seas, and some of the earliest forms of life, simple, single-celled organisms that were just beginning to experiment with photosynthesis, pumping the first whiffs of oxygen into our atmosphere. But nothing on Earth stays the same for long. Kennerland's reign lasted for about 200 million years before it began to break apart. The forces of plate tectonics, the engine that drives continental movement, were relentlessly at work, tearing the supercontinent asunder. The cycle continued. The pieces of Kennerland drifted for a while before beginning to converge once again. Around 1.8 billion years ago, they came together to form the supercontinent Columbia, also known as New. Columbia was massive, stretching an estimated 12,900 kilometers from north to south. This was a critical time for life. The atmosphere was becoming richer in oxygen, leading to more complex cells evolving in the oceans. Imagine a world where the land was still barren rock, but the seas were teeming with new biological innovations. Columbia held together for about 500 million years, a long period of relative stability, before it too succumbed to the immense geological forces pulling it apart. Next on our supercontinent timeline is Rodinia, which formed about 1.1 billion years ago. The name Rodinia comes from a Russian word meaning to give birth, and it's fitting, because it from the breakup of Rodinia that the continents we are more familiar with eventually emerged. Rodinia was a game-changer. Its formation and eventual breakup had a profound impact on Earth's climate. The breakup led to the creation of new oceans and changed ocean currents, which may have triggered a series of extreme ice ages known as Snowball Earth. During these periods, the entire planet might have been covered in ice, from the poles to the equator. It was one of the most severe climate crises in Earth's history, and it pushed life to its absolute limits. But life is resilient. As Rodinia broke apart and the ice retreated, life exploded in diversity during the Cambrian explosion. The fragments of Rodinia drifted and eventually began to reassemble. A few smaller supercontinents formed in the southern hemisphere, including Pangaea and Gondwana. Gondwana was a giant, composed of what would become modern-day South America, Africa, Antarctica, Australia, the Indian subcontinent, and the Arabian Peninsula. At the same time, other continents, like Laurentia, which is the core of North America, existed independently. Finally, we arrive at the most famous supercontinent of them all, Pangaea. Around 335 million years ago, Gondwana collided with the northern continents, bringing nearly all of Earth's land masses together into one colossal supercontinent. Pangaea, meaning all Earth, was surrounded by a single immense ocean called Pangaea. Life on Pangaea was incredible. Giant insects flew through the air, and early reptiles and amphibians roamed the vast interior. This was the world of the dinosaurs' ancestors. The climate in the center of Pangaea was likely very dry and extreme, with scorching hot summers and freezing cold winters. But like all its predecessors, Pangaea was not destined to last. About 175 million years ago, during the age of dinosaurs, it began to rift apart. First, it split into two large landmasses, Laurasia in the north and Gondwana in the south, separated by the newly forming Tethys Sea. Then, these two giants continued to break apart. The Atlantic Ocean opened up, pushing the Americas away from Europe and Africa. India broke away from Antarctica and began its long, rapid journey north, eventually colliding with Asia to create the mighty Himalayas. Australia split from Antarctica and drifted to its current position, and that brings us to the world we know today. The 7 continents we live on are the scattered remnants of Pangaea. The process isn't over. The continents are still moving, at about the same speed your fingernails grow. The Atlantic Ocean is getting wider, while the Pacific Ocean is shrinking. Geologists predict that in the distant future, perhaps 250 million years from now, the continents will once again merge to form a new supercontinent, sometimes nicknamed Pangaea Ultima or Amasea. So the next time you look at a globe, remember that you're only seeing a snapshot in a 4 billion year long story of constant change. Our planet is a dynamic, living system, and its surface is forever being reshaped. From Vaalbara to Pangaea and beyond, the epic story of our landmasses is a powerful reminder of the incredible forces that have shaped our world and continue to shape its future. Thanks for joining me on this incredible journey through deep time.